planet Jupiter has 95 moons that are officially recognized by the International Astronomical Union, but the collection of objects around Jupiter is way more complicated than just that simple number. The planet is host to a complex system of rings, moons, and asteroids, and there are thousands of small objects in orbit around it. Many of the moons of Jupiter have names based on mythology. They're typically named after figures related to the Roman god Jupiter or his Greek equivalent Zeus. However, nowadays, these smaller moons won't be given a mythological name unless they are of significant scientific interest. They will just be given a sort of code name or identifier instead. Jupiter's 4 largest moons were the first moons discovered beyond Earth. Prior to their discovery, it was assumed that only Earth had a moon. They're called the Galilean satellites after Galileo Galilei, who discovered them in 1610. Galileo wasn't the only person who discovered Jupiter's largest moons around this time, though. The German astronomer Simon Marius also discovered them, but he's kind of forgotten because Galileo published his findings first. However, the names that Marius proposed for the moons, which were suggested to him by Johannes Kepler, are still in use today: Io, Europa, Ganymede, and Callisto. These large moons likely formed from material that was left over after Jupiter condensed out of the disk of cloud and dust that used to surround the sun at the beginning of the solar system. The smaller moons, especially the outer ones, are generally more likely to be captured asteroids. 3 of the 4 large moons, Io, Ganymede, and Europa, are in what's called an orbital resonance with each other. This means their orbits sync up in some way, although it's not a one-to-one relationship. For every time Ganymede orbits Jupiter once, Europa orbits twice, and Io orbits 4 times. It's believed that the 4th Galilean satellite, Callisto, will eventually fall into this orbital resonance. Let's fly right on in and learn some more about the moons of Jupiter. Ganymede is the largest moon in the solar system. This thing is pretty big. It's even larger than Mercury and Pluto. This moon gets its name from a figure in Greek mythology. Ganymede was carried to Olympus by Zeus disguised as an eagle. He became the cupbearer of the Olympian gods. Ganymede, the moon, not the mythological figure, has a radius of around 1,635 miles, and it orbits around 665,000 miles from Jupiter. It completes one orbit around Jupiter around every 7 Earth days. It's tidally locked with its host planet, just like our moon is to Earth. While it's bigger than Mercury, it only has about half the mass, so it also has a much lower density. This low density indicates that Ganymede is made up of about half rock and half water ice by mass. Notably, there's some pretty strong evidence of an underground saltwater ocean on Ganymede. This ocean might hold more water than what exists on Earth's surface. And Earth is like 3/4 water, so that would be a lot. This ocean is estimated to be about 60 miles deep and buried under a 95-mile thick layer of ice. Primitive life could be possible within this ocean. Ganymede has 3 main layers: a metallic iron core at its center, a shell of rock called the mantle that surrounds the core, and a shell of mostly ice that surrounds the mantle. The surface of the moon is the very top of this ice shell. Within Ganymede, there could be layers of ice and ocean stacked up like some kind of weird club sandwich, although that's not a sandwich I would want to eat. That would be a very, very watery sandwich. Irregular lumps have been found beneath the ice of Ganymede's surface. These could be rock formations that the icy shell has supported for billions of years. Ganymede features 2 distinct types of terrain. First, there's the large, bright regions that cover about 60% of the moon's surface. The other 40%, on the other hand, is covered by darker, grooved terrain. The grooves are likely the result of tectonic activity or water being released from underneath the surface. Some of the groove ridges are 2,000 feet high and run for thousands of miles across the surface. There's plenty of craters on Ganymede, and the larger craters are mostly kind of flat. In images of the moon, you can see bright and dark rays of ejecta around these craters. These are trails of material that were ejected during an impact. Ganymede might have a thin oxygen atmosphere, and this atmosphere could be coming from its icy surface. The moon is very cold. Daytime surface temperatures range between the very, very high and hot values of -297 and -171 degrees Fahrenheit. Because it's so far away from the sun, Ganymede receives a lot less sunlight than Earth, and its atmosphere is nowhere near enough to trap heat. Thus, it's very cold. Ganymede is the only moon known to have its own magnetic field. Since it's so close to Jupiter, its magnetic field is embedded entirely within the planets. The moon's magnetic field causes auroras that circle its poles. Ganymede is pretty cool, huh? No, really, it's cold. It's cool. Very, very cold. You better bring a winter jacket if you want to go there. Anyway, let's move on to the next moon now. Callisto is the second largest moon of Jupiter and the third largest moon in the solar system. It's about the same size as Mercury. It's also the most heavily cratered body in the solar system and the furthest out of the Galilean satellites. Callisto takes its name from a woman who attracted Zeus in Greek mythology and was later turned into a bear. Exactly who turned her into a bear tends to vary between the versions of the story, which happens with a lot of ancient tales. This moon has a radius of about 1,500 miles, and it orbits more than 1,000,000 miles away from Jupiter. It takes around 17 Earth days to make a complete orbit around its planet. Like Ganymede, it's tidally locked and only ever shows one side of itself to Jupiter. Because it's much further away than the other Galilean moons, it experiences far fewer tidal forces. Just like its buddy Ganymede, Callisto is very cold. All of the moons of Jupiter are pretty cold, actually. Its average surface temperature is around negative 218 degrees Fahrenheit. Images of Callisto show these bright white spots that stand out against the moon's darker regions. These bright spots are likely ice, while the dark patches are places where ice has eroded. This icy surface is covered in impact craters of various shapes and sizes. Some of these are pretty impressive. The Valhalla Impact Basin is the largest multi-ring crater in the solar system. This heavily cratered surface implies that Callisto experiences very little or no geologic activity. There aren't any active volcanoes or tectonic shifts that could erode the craters, so they just kind of stay there forever. Measurements of Callisto's gravity field indicate that its interior is not differentiated. Whereas other bodies are separated into the iconic core mantle structure, Callisto isn't. Its interior is a bunch of ice and rock mixed together rather than split into separate layers, and there could even be some metal in there. While Callisto doesn't have any sort of substantial atmosphere, the Galileo spacecraft detected a very thin carbon dioxide exosphere. An exosphere is just a very thin and light atmosphere. More recent research into this exosphere indicates the presence of oxygen and hydrogen in addition to the carbon dioxide. Speaking of the Galileo spacecraft, some data it collected indicated that Callisto might have an ocean about 155 miles beneath its surface. However, more recent research indicates that either the ocean is further down than originally thought, or it just doesn't exist at all. If the ocean exists, it could be interacting with rock, which would give Callisto a chance of supporting life. So there's Callisto. The poor little guy has been beat up a lot. Well, maybe it hasn't really been hit that much more than any other body, it just doesn't have a way to get rid of the craters. Io is known as the most volcanically active body in the solar system. It's covered in hundreds of volcanoes, some of which erupt lava that rises dozens of miles above the surface. Io, like a lot of Jupiter's moons, takes its name from a woman in Greek mythology. This woman was transformed into a cow during a marital dispute between Zeus and his wife Hera. Seems like a lot of women get caught in the crossfire between those two. This moon is caught in a weird sort of tug of war between Jupiter's gravity and smaller but precisely timed tugs from other moons Ganymede and Europa. Because of this eternal cosmic game of tug of war, Io is subjected to a lot of tidal forces. These tidal forces generate heat, which drives the moon's volcanic activity. Sometimes Io's volcanoes are so powerful they can be seen with a large telescope from Earth. Imagine looking up into space and seeing a volcano erupt on another planet's moon. That would be incredible. Io has an average radius of around 1,130 miles. Because of the way Jupiter, Europa, and Ganymede pull on it, its shape is slightly elliptical. Its longest axis is pointed towards Jupiter because it's tidally locked to the planet. Io orbits Jupiter at an average of around 262,000 miles away, and it takes about 1.77 Earth days to complete an orbit. Europa and Ganymede make Io's orbit highly elliptical, so it's not always the same distance from Jupiter. The tidal forces that act on the moon cause its surface to bulge out as much as 330 feet. Io's orbit takes it across Jupiter's magnetic field lines. This basically turns the moon into an electric generator. It can develop 400,000 volts across itself and create an electric current of 3 million amperes. Now, I don't really know what any of that means because I'm not an electrician, and quite frankly, I know very little about electricity, but that sounds like a lot. Those are pretty big numbers. This electric current from Io makes its way back across the the magnetic field lines to cause lightning storms in Jupiter's upper atmosphere. It's like Io is spitting at Jupiter and making it very angry. Because of all the volcanoes, you might expect Io's temperature to be a lot hotter than the other moons, but its average surface temperature is only around -202 degrees Fahrenheit. Inside the volcanoes, however, temperatures can reach 3,000 degrees Fahrenheit, which that's pretty hot. That's even hotter than Venus, which is the hottest planet in the solar system. It's not hotter than the sun, though, which is the hottest thing in the solar system, probably, I think. I'm willing to bet on it. Unlike the other Galilean moons, Io's surface is constantly renewing itself. Molten lava fills impact craters so quickly that there's basically no evidence of them. While something like Callisto has very little or no surface activity, Io is very, very active. Beneath Io's crust is a layer of molten rock, followed by a core of molten iron and iron sulfide. The composition of material within Io is not yet clear, but it might be largely molten sulfur and its compounds, or silicate rock. Io's surface is primarily composed of sulfur and sulfur dioxide. Sulfur dioxide is also the primary constituent of the moon's very thin atmosphere. This atmosphere is sort of collapsible when it's behind Jupiter, and in its shadow it freezes up and then turns into a gas again when it's back in sunlight. Jupiter's magnetic field strips a ton of material off of Io every second. This material becomes ionized and forms a donut-shaped or toroidal cloud of intense radiation called a plasma torus. Some of these ions are pulled into Jupiter's atmosphere along the magnetic field lines and create auroras. These ions escaping from the torus are responsible for inflating Jupiter's magnetosphere to twice the size you would expect. Io is really cool. Look at all those volcanoes. Well, you can't actually see them, but you know they're there. Isn't that neat? Europa is the 4th largest moon of Jupiter and the 6th closest to the planet. It's named for a woman abducted by Zeus in Greek mythology. Zeus was out here abducting a lot of women, and that's kind of what he's known for. He's known more for abducting women than being, the king of gods and all. Europa has a diameter of around 1,940 miles. It reflects 5.5 times more sunlight than our moon, so if it was in our sky, it would look pretty damn bright on a full moon night. Europa orbits Jupiter at a distance of around 417,000 miles, and it completes an orbit every 3.5 days. Like the other Galilean satellites, it's tidally locked and shows only one side of itself to Jupiter. This moon is primarily made of silicate rock. It has a crust made of water ice. That's frozen water, ice made from water, not the summertime treat. The core of the moon is probably a mix of iron and nickel. Europa has a very thin atmosphere composed primarily of oxygen, but there are also traces of water and hydrogen. Cracks and streaks striate its surface, and there aren't that many craters. Its surface is very smooth compared to other icy moons, and it's even considered the smoothest object in the solar system. Its highest peaks, and there aren't very many of them, are only a few hundred meters tall, and impact craters just kind of don't exist that much. This thing is like a polished marble out in the middle of space. The icy crust makes Europa one of the most reflective moons in the solar system. Surface temperatures average about -260 degrees Fahrenheit. The lack of impact craters tells us that the surface is relatively young, and there must have been something that erased other craters that once existed. This could have been icy volcanic flows, or the icy crust settling under its own weight. This surface, which is estimated to be no more than 40 to 90 million years old, which is a long time but very small on a cosmic scale, is blasted by radiation from Jupiter. Europa's elliptical orbit causes tidal forces to stretch and relax its surface. The fractures on its surface are likely the result of these forces. Along these fractures is a reddish-brown material. The composition of this material is not known for certain. It likely contains salt and sulfur compounds mixed with water ice and modified by radiation. But the thing Europa is most famous for is its likely saltwater ocean underneath its surface. This ocean is estimated to be twice as large as Earth's global ocean, and it may contain chemical ingredients that are key for life. In fact, Europa is considered one of the biggest candidates for finding life in our solar system. Europa's subsurface ocean was first hypothesized when the Galileo spacecraft discovered that Jupiter's magnetic field is kind of disrupted around the planet. This strongly implies that a special type of magnetic field is created or induced within Europa by a layer of electrically conductive material somewhere beneath the surface. The most likely material to create this weird magnetic signature is a global ocean of salty water. Europa's ice shell is between 10 and 15 miles thick and floats on an ocean that could be 40 to 100 miles deep. That's way deeper than even the deepest part of Earth's ocean. Astrobiologists believe this moon has plenty of water and all the right chemical elements for life. Life doesn't just need water, though, it also needs energy. On Earth, life gets its energy from the sun. Plants make energy using photosynthesis with sunlight, and then animals eat those plants, and then other animals eat those animals, and so on and so forth. I think you get the point. But sunlight doesn't reach beneath the surface on Europa. So if there is life on the moon, its energy probably comes purely from chemical reactions. In fact, that was how life on Earth used to exist before some organisms developed photosynthesis. Europa could be actively venting water into space, which would mean there's current geological activity on the moon. In 2019, an international research team announced the detection of water vapor. It would be so cool if there's life on Europa. It definitely wouldn't look anything like life on Earth, and it might just be a bunch of microorganisms floating around in a chemical soup, but it would still be fascinating. It would prove that we're not really alone in the universe, or even in our own solar system, even if our only buddies are just some little guys. Most of Jupiter's other moons orbit much further out than the Galilean satellites. Among the distant moons, larger ones are likely to be captured asteroids, while smaller ones could be fragments left over from an impact. Pieces of a larger moon that got blown apart by something hitting it. The modern astronomer Scott S. Shepard has discovered the most moons of Jupiter. If you look at the list of the planet's moons, his name shows up everywhere in the Discoverer section. He's decided to dedicate himself to one thing, and that thing is finding the moons of Jupiter, and I can respect that. About 60 of Jupiter's moons are less than 6.2 miles in diameter, which makes them very small. The outer moons usually orbit in the opposite direction to Jupiter's rotation, which supports the idea that they are captured asteroids. All the other moons aren't really as significant or noteworthy as the Galilean moons, which makes sense because they're basically just a bunch of chunks of rock floating in space. The fifth largest moon, Amalthea, was the first one discovered after the Galilean satellites. It takes only 12 hours to make a full orbit around Jupiter. It was the last satellite to be discovered by direct observation with a telescope. Everything else since then has been found using images taken by a device like a probe or a satellite. Amalthea is irregularly shaped with an average radius of 51.88 miles, and its surface is marked by impact craters, hills, and valleys. It contributes to the faint outer gossamer rings of Jupiter. It takes its name from a naiad or water nymph that nursed the infant Zeus with goat milk in a cave in Crete. Interestingly, Amalthea is the reddest object in the solar system. Astronomers estimate that it will eventually lose its orbit and crash into Jupiter. Like Amalthea, the innermost moons contribute to Jupiter's ring system. The Galilean satellites, on the other hand, make large rings impossible. They would just destroy them with their gravity, which is why Jupiter doesn't have fantastic rings like Saturn. As I mentioned way earlier on in this video, new moons will no longer be given mythological names. The only exception is if they're important somehow, and my best guess is that astronomers got tired of running to the mythology textbooks every time a new moon of Jupiter came up. And that's all I've got about Jupiter's moons. There's a lot of them, and there's basically no information worth relaying about most of them. The Galilean moons are understandably the most thoroughly studied, so there's way more information available on them. I hope you enjoyed this little exploration of Jupiter's moons. Thanks for watching, like and subscribe if you enjoyed, because I will have more space videos on the way, and have a good day.